Hello, how are you doing? And let's look at some of the question here. And it's a question from Ohm's law. And I got it from a Form 3 Term 3 Paper 2 question. And is how it looks like. Now we are having a 4 ohm resistor and 6 ohm resistor. And then we are having 5 ohm resistor connected to those two 4 ohm and 6 ohm resistor. And all of that is actually connected to 2 ohm resistor. And all of this arrangement is connected to 10 volts supply. Now, for this case, we are going to be having this question, determine the total resistance. Now, how are we going to determine the total resistance here? Now, that's where we are going to our solution. Now, let's start with this arrangement. 4 ohm resistor and 6 ohm resistor. Now, all of this is connected to some 5 ohm resistor, 5 ohm resistor. And this arrangement is in parallel with this arrangement, but this one is in series with this resistor. Now, how are we going to find the total resistance in this one? Now, for this case, we are going to have the total resistance, the resistance of 4 ohm and 6 ohm resistor in series. Now, how are we going to do it? Now, it's simply because we are going to be 6 ohm resistor, 6 ohm plus 4 ohm. Now, remember these are resistors in series. Now, when the resistors are in series, to find the total resistance, we simply add them. As simple as that. So, what are you going to get there? 6 plus 4. It becomes 10 ohm. Nice one. Now, let's go to the next thing, which is very interesting. Now, once you have found this 10 ohm resistor, now we are going to assume that this 10 ohm resistor is now going to be in parallel with the 5 ohm resistor. 5 ohm resistor. That's because we are having a junction here. Anytime we are having a junction for this case, then it means that we are having something in parallel. Now, when two resistors are in parallel, then to find the total resistance, it's simply going to be R1 multiplied by R2 divided by R1 plus R2. Now, what are we going to have there? So the R total through this one is actually going to be, so the resistance of 10 ohm and 5 ohm is going to be 10 multiplied by 5 divided by 10 plus 5. So that becomes 50 divided by 15. So that becomes, so R is going to be 50 divided by 15, and that's going to be 3.33 when you're going to use the calculator. That's it. Now, once we have reached here, already we are having the resistance for this 10 ohm and 5 ohm. So it is, let's call this one R1. Now, we are having R1, and then we are going to have something like this, the 2 ohm resistor. Now, the 2 ohm resistor, let's call it R2. And this one is also connected to what? A 10 volts power supply. Now, how are we going to find the total resistance now? The final total resistance. So the final total resistance, remember, R1 and R2 are connected in series since there is no any junction between them. So for this case, we are going to have 3.33 plus 2. So the total is going to be 5.33 ohms. So it's as simple as that. Now, we have found that. Let's go to the question Roman 2. So the Roman 2 question is actually asking us to find the total resistance. So the total, it is the total current. So how are we going to find the total current? Now, to find the total current is simply simple. Look at this. It's going to be current, the total current is simply going to be the voltage, the total voltage divided by the current combined, or the resistance combined, or the total resistance, which is actually going to be we add 10 divided by the total resistance, which is 5.33. Now that's going to give us 1.876. Now, anytime you are calculating something using a calculator in physics, always make sure you leave it in 4 significant figures. That is very important. Now, in Roman 3, we are actually asked to find the total voltage across the 2 ohm resistor. And the 2 ohm resistor, now let's look at this. We actually had 5.33 and it is connected in series with the 2 ohm resistor. And this one is connected to 10 ohm supply. Now, there's one thing that you should understand here, that the total current from the supply is the same current that will go through 5.33 ohm, and it's the same current which will be going through the 2 ohm resistor. Now, that is when the resistors are connected in series, the current does not change. However, there is some voltage drop. So there'll be a voltage drop across 5.33 and there'll be a voltage drop across 2 ohm resistor. So the voltage across this one will not be the same voltage across this one. So the potential difference here will be different, but the current will be the same. So for this case, once we are having the total current, remember we already calculated the total current, to find the voltage across 2 ohm will simply become, so the resistance or the voltage across the 2 ohm will simply become, now we know voltage is given by IR, but it will be the I total, the total current, multiplied by the resistance 2 ohm. So it is the 2 ohm resistance. So what will that give us? 1.876 multiplied by the 2 ohm. So it will be multiplied by that. What are we going to get? So it's going to be 3.75 volts. That's all. See you in our next video. Make sure you subscribe to this channel for more contents like this.